Hey guys, welcome. In this video, I'm going to talk about multiplying and dividing rational expressions. So to start with, I want to review a little bit, just connect back to thinking about fractions. Fractions are a kind of rational expression. We have a ratio of two things. So when we're reducing fractions or simplifying fractions to lowest terms, we want to take out any common factors. So for example, 10 over 15, we say, well, they both have a factor of 5. 5 goes into 10 twice, 5 goes into 15 3 times. So that's our lowest terms expression for 10 over 15, which is equivalent to 2 over 3. Now, for multiplying fractions, we can also do some reducing or simplification before we multiply them. I mean, we could multiply this out to say 3 times 4 is 12, 8 times 9 is 72, and we'd have 12 over 72, but that would not be in lowest terms. We'd still have to do some simplification. But we can do that ahead of time, remember? So let's look this direction. We can say, well, 3 goes into itself once, and 3 goes into 9 3 times. We can do simplifying this direction. 4 goes into itself once, 4 goes into 8 2 times. So then we just multiply across the tops and across the bottoms, and we get, oh, I wrote 2 equal sign there, just ignore that. 1 times 1 gives us 1, 2 times 3 gives us 6. And it's very important, remember, when we cancel something out and it's in the numerator and it just leaves us with 1, remember to write that 1 in your final answer. I've been alarmed sometimes to see people just write like the denominator as just a number or an expression, and that is completely wrong. So please don't do that. Please remember to write the 1. That's one of the most common errors I see. But when people are aware of it and watch out for it, then they don't make that error, and of course that's going to improve your grade, help you get through your homework faster, etc. So keep that in mind. Now, when we have rational expressions like these, and we're going to multiply them, we can do the same thing. Actually, let me switch colors here. Maybe we'll make this a little easier to see, because I just want to write this straight above here. Instead of x squared minus 16, we can write that in its factored form, because that's a difference of squares, so it's going to factor into x plus 4 times x minus 4. Down here, we have 2x plus 6. That's got a GCF of 2, so we can write 2 times x plus 3. In this rational expression, we don't have any factoring to do. So now we can look diagonally, in each direct, diagonally here, diagonally there, and see if there's anything we can cancel. Well, we can cancel out the x minus 4 terms, and we can cancel out x plus 3. Now, you could even write, a 1 there if you want. But that's all the canceling that we can do. And so our final answer for this, again, multiply across the tops. Well, that's just x plus 4 times 1. So we have x plus 4. And in this denominator, let's see, right, we canceled out the x plus 3's, and so we just have 2. So that's the final answer for that. Okay, another thing to really be cautious about is sometimes people are tempted to cancel something like the 4 and the 2, but we cannot do that because we've got a addition sign here. If you have addition or subtraction between things, you cannot cancel. You can only cancel factors, only things that are being multiplied. All right, let's look at another example. X plus 5 over 14 times 7 over x squared minus 25. All right, so we've got, I'll just write this over this direction, x plus 5, and we can factor the 14 as 2 times 7, and then times 7 over, and what's this? Again, we have a difference of squares, so how's that going to factor? X plus 5 times x minus 5. All right, so let's start seeing where we can cancel out some stuff. X plus 5 cancels with x plus 5 that way, and 7 cancels with 7 that way. So here I'm setting you up for trouble, right? So what about this 7, and what about this x plus 5? Does that mean there's nothing left up here? There's a 1 in each case. 7 goes into itself once, 7 goes into 2 times 7 2 times, right? So that's what's left there. So we multiply across the tops, we just get 1, and across the bottom, we have 2 times x minus 5. All right, now let's look at a division problem. So 4x squared minus 1 over x squared minus 4 divided by 2x minus 1 over x minus 2. All right, so recall, going back to the fraction idea again, let's say we have 3 over 7 divided by 1 over 5. So recall from your learning of fractions that when we have a division problem with fractions, we're going to change it to a multiplication problem. We keep it, change it, flip it. All right, so keep it, 3/7. Change it, we change this right here to multiplication, and then we flip it. The 1/5 becomes 5 over 1. And then we're back to regular multiplication. We multiply across the top and across the bottom, and that's our answer, 15 over 7. So applying that same principle to multiplying rational expressions, I'm just going to first rewrite this as keep it, change it, flip it. So I'm keeping the first expression just as it is, I'm changing the division to multiplication, and I'm flipping the rational expression over here. So keep it, change it, flip it. All right, now I'm going to do some factoring. All right, another difference of squares here. 2x plus 1 times 2x minus 1. And then another difference of squares there. X plus 2 times x minus 2. Over here, I don't have anything to factor. Sometimes I like to put these in parentheses, kind of makes them look more similar to what I'm going to cancel with. So right away, I see these guys will cancel. The x minus 2 in that direction, and then 2x minus 1 I can cancel in that direction. And then my final answer, I just multiply across the tops and across the bottoms, and I get 2x plus 1 over x plus 2. And that's the final answer for that one. So that's just a quick review of multiplying and dividing rational expressions. As always, thank you for watching.